Hi all, today we discuss section 22.2, differences of factorial polynomial. So first we define what is a factorial polynomial. This is defined for a positive integer n. So if we start with n is a positive integer, then we consider the expression, x into x minus h into x minus 2h etc. into x minus n minus 1h. So this is the product of n factors. That means this contains n factors beginning with h and decreasing by h every time, and this is called a factorial polynomial. It's called a factorial polynomial. Of degree n, and this is denoted by x of n. So this is a factorial polynomial in x of degree n. So this is denoted by x of n, that is x into x minus h into etc. x minus n minus 1 times h. For considering each factor, then this factor is diminishing by h from the previous factor. So this is the product of n factors. If we consider the first term is x minus 0 times h, then all the way up to n minus 1 times h, we will get n factors. So for example, x of 1, it is a polynomial of degree, factorial polynomial of degree 1, and it contains only one factor, x. Similarly, what is x of 2? So it contains two factors starting from x, and the other will be x minus h, diminishing by h. And similarly, x of 3 is nothing but x times x minus h times x minus 2h. Okay, this is the way we define the factorial polynomial of degree 1, 2, 3 and so on. And now we will define the difference of such polynomial, difference of factorial polynomials. That means delta of x of n. What is the difference? This is defined to be x plus h of n, that is obtained by replacing this x by x plus h in this expression, and minus x of n. So this is the definition we have defined earlier. This is the delta, forward difference of any function f of x. So for this factorial polynomial, this will be the forward difference. And if we simplify this, you can write this is this x plus h of n. So this starts from x plus h, and we will collect n terms from this x plus h by diminishing h in each consecutive factors. So this, for the first term will be x plus h, and the second term will be x plus h minus h, that is x itself, and next will be x minus h, etc., etc. We have x minus n minus 2h. If we consider these terms, product of these terms, that will constitute x plus h of n. That means the factors, the n factors starting from x plus h. So this is x plus h. We know that if we start from x minus 0 to 0h to x minus n minus 2h, we have n minus 1 factors, and including this x plus h, we will get total n factors in this bracket. Minus we have this x of n, that starts from this x times x minus h times etc. x minus n minus 1h. This is the definition of x of n. Now we will consider the difference between these two polynomials, that will give the forward difference of x of n. So when you observe these two brackets, we can say that from these factors, these the factors from x2 x minus and minus 2h, these factors are common in both the brackets, so we can take it out. So that starts from x times x minus h, etc., x minus n minus 2h. Okay, so this is the common factor from the bracket. Next we have in the first term we have x plus h, and in the second bracket we have the common factor will be we take this factor out, then the last term will be this is the last term, x minus n minus 1 times h. So these are the factors remaining in two brackets. So we have this is the product of this. So we constitute this as x of n minus 1, because this is the product of n minus 1 terms starting from x minus 0 h, x minus 1 h, except x minus n minus 2 h. So this contains exactly n minus 1 term starting from x. So this will be x of n minus 1, and this bracket will give x plus h minus, this is x plus h minus x plus n minus 1 times h. So that will be this bracket, and this will be x n minus 1. So this is a factorial polynomial of degree n minus 1 starting from x, and we can cancel these two x's, and the remaining will be and we can cancel one more h also, so the remaining will be n times h. So this will be, that is n times h, x n minus 1. Okay, this can be considered as a recurring formula, or this forward difference of x of n is in terms of x of n minus 1, that is n times h times this. Okay, now if you evaluate del square of x n, this is the del square of x of n, that will be del of x of n. But we know that what is del of x of n, so that will be del of this quantity n times h times x of n minus 1. So this is n times h times x of n minus 1. But we know that these are two constants, so that can be taken out from the forward difference that we have already discussed in the previous classes. So that will be n times h del x of n minus 1. So how will you find this del of x of n minus 1? That is using this formula again. If we have n here, then the result will be n times h times this. So now we have n minus 1 here, so that will, here we have n times h is already there, and we have n minus 1 here, so that will be n minus 1 times h times this x of n minus 2. So this will be the del square of this. So we write del square x of n, that is the second order forward difference of x of n, will be n times n minus 1 times h square. So this n into n minus 1, that is obtained here, h square times x of n minus 2. So using these recurrence, you can easily write what is third order difference of the same factorial polynomial of degree n. So that will be delta 3 of x of n, that is equal to, here we have n minus 1 and n minus 2 will be there, and here we have h cube will be there, and this will be x of n minus 3. Okay, so if you repeat this process, what will be delta n of x of n? Okay, so that is obtained by replacing these quantities as n times n minus 1 times etc. N minus 1 into 1. So if here we have 3 symbol, if we have 3 here, then we have 3 terms will be there. If we have n here, then we have n terms will be there, starting from 1 and all the way up to n. So that will constitute n factorial. Later we will replace that by n factorial, and we have h of instead of 3 we have h raised to n, and this will be x of n minus, when we have 3 here, then that will be n minus n, so that is 1 itself. Okay, so we write this is the delta forward difference, nth order forward difference of x of n. So that will be we write this as n factorial times h raised to n. So the nth order forward difference of the nth degree factorial polynomial is a constant. Okay, obviously the n plus 1th order of this polynomial, the same factorial polynomial of degree n, if we start with any factorial polynomial of degree n and take the n plus 1th order of the forward difference, then that will give 0, because that is the delta of this constant. Then we know that the delta of the constant is always 0. So n plus 1th degree of n plus 1th order of forward difference of nth degree factorial polynomial will be 0. Okay, so we have two remarks on this. The first one will be this forward differencing is nothing but that is analogous to the differentiation. Okay, when you consider the first formula, that is delta of if you consider this is analogous to the differentiation, then that will be delta of x raised to n, that is in terms of hn times delta of, or this is x of n minus 1. So this is analogous to n times x raised to n minus 1 with this differentiation factor. So this is analogous to the differentiation. So we write differencing is analogous to differentiation. And similarly, the process of getting the function whose first differences are given is analogous to the integration. Okay, the process of getting the function whose first differences are given is analogous to the integration. Okay, so or we will expect all the properties of integration and differentiation for this these two processes. Okay, now we will discuss a problem to find the successive differences of a factorial polynomial, and how to find a function whose first difference is the given function. Okay, so next we have a illustrative example. So in this example we have a function f of x equal to 2x square plus 3x square plus 3x square minus 5x plus 4. We have a function. The first problem is how to express this f of x in terms of factorial polynomials. Okay, that means we need to express this f of x as a linear combination of the factorial polynomials, that is a0 times x raised x of 3. Since this is a third degree polynomial, this is 2x cube, we express this third degree polynomial in terms of third degree, second degree, first degree factorial polynomials. So that is a0 times this, and a1 times x of 2 plus a2 times x of 1 and plus a3. Okay, so these a0, a1, a2, a3 are to be determined. So next we will illustrate a procedure to find out these a0, a1, a2, a3, etc. So in order to get those a0, a1, a2, a3, etc., we follow we will trace the following procedure. So first you collect the coefficients of this polynomial 2, 3, minus 5 and 4. And one thing you should remember is your polynomial should be in standard form. So we collect those coefficients 2, 3, minus 5. We need to find out the remainder of this polynomial when it is divided by x. So that is the first process. But we know that the first three terms of this polynomial contains x. Therefore, the 4 will be the remainder. Or otherwise, you can use the synthetic type of division in order to divide this polynomial with x minus 0. We write 0 here, and we use the synthetic type of dividing. So we place 2 here and consider the multiple of 0 and 2. So that will be 0 again, and when we add these 2, 3 and 0, we will get 3 here, and multiply this 3 with this 0, and that will this 3, this 0 and this 3, then that will give 0 into 3 again, 0 here, and add these two numbers, and we will get a minus 5 again, and multiply this minus 5 with 0 again, so that is again 0, and we know that this will be the we know that these first three terms contains x, so therefore this will be the remainder, and the next will be the this is 4, and if you collect all the way up to this, you can get the remainder here. And next we will, so this is analogous to dividing the polynomial with x minus 0, and next we need to find out the remainder of this polynomial with x minus 1 when it is divided by x minus 1. So we use the same synthetic formula, synthetic method of dividing, so that will give, so we noted this as our a3. Okay, this is going to be the a3, and we consider x minus 1, the factor x minus 1, divide this with x minus 1. For that we write 2 here, and we have 2, and we have 5 here, this is minus 5, and we have sorry, this is plus 5, and when we add these two, you can get 0, and move this, separate this part, this is going to be a2, and we have, next we need to divide the polynomial 2x plus 5. So this when you divide this polynomial 2x cube plus 3x square minus 5x plus 4 with x, you will get 2, 3 minus 5 here, and 4 is the remainder. This corresponding to this, we can write this 2x cube plus 3x square minus 5x plus 4, that can be written as, using these three coefficients, 2, 3 minus 5, that is 2x square plus 3x minus 5 times this factor x minus 0 plus 4. So this is the meaning of 2, 3 minus 5 and 4. Okay, when you write this one. Now using the synthetic method of division, you will get a new quotient 2, 3 minus 5. So when you consider those polynomial, that is 2x square plus 3x minus 5, that represents the coefficients of this polynomial is obtained here, 2, 3 minus 5, and we will divide this polynomial with x minus 1. Okay, then you will get these two numbers 2, 5. What is the meaning of that? You can express this 2x square plus 3x minus 5 can be written as this 2x plus 5 times x minus 1 plus 0. So this is the meaning of this. When you multiply this, you will get 2x square here, and 5x minus 2x, that is 3x here, and 5 times minus 1. That is the meaning of these three coefficients 2, 5, 0. Okay, that means when you divide 2x square plus 3x minus 5 by this x minus 1, then this will give the quotient polynomial, and this will be the remainder. Okay, then you repeat this process with x minus 2. Okay, so when consider x minus 2, that means write this 2 here, and place this 2 here, then multiply it with this 2, then that will be 4. Then you will get 9. By adding this you can get 9 here. So when we separate this 9, you can say that will be the remainder, and this will be the quotient. Okay, so this is the final step. That means what is the meaning of this? That is, you can write 2x plus 5 that comes from these two coefficients, that can be written as 2 times x minus 2 plus this remainder. That is the meaning of this. Okay, so this procedure is analogous to, or that is same as the dividing this polynomial with x first, and dividing the quotient polynomial with x minus 1, then dividing that quotient x2x plus 5 with by this x minus 2 again. So you will get this is the reminders, then this is going to be our this is a3 and this is a2, and we have this is a1, and if you write 2 here, you will get by dividing this with x minus 2, you then this is the remaining polynomial. So this corresponds to a0. Okay, so using this a0, a1, a2, a3, you can write this is nothing but 2 times x of 3 plus 9 times x of 2 plus 0 times x of 1 plus 4. Okay, that is x of 0 is nothing but 1. So this is the way we express any polynomial f of x in terms of the factorial polynomial. Now next we will find how to get a function that is going to be the first difference of the f of x. Okay, so next is the so we will show how to find out that. That means we need to find out f of x, capital F of x, such that the first difference of capital F of x is going to be small f of x, that is 2x square plus 3x square, 2x cube plus 3x square minus 5x plus 4. Okay, so in order to find out this capital F of x, we use a notation by transposing this delta to this, that is 1 by delta f of x. Okay, so this is going to be this is a notation 1 by delta. This is we already seen that this delta is analogous to the differentiation, so this 1 by delta is analogous to the integration. So when you write this polynomial f of x as 2 x raised x of 3 plus 9 x of 2 plus 0 times x of 1 plus 4. So this is the way we write this polynomial as a linear combination of factorial polynomial. So we need to apply this 1 by delta to this 2x of 3 plus 1 by delta of 9x of 2 plus 1 by delta of 4. We know that we need to find out this 2 times 1 by delta of x of 3, okay, plus 9 times 1 by delta of x of 2 plus 4 times 1 by delta of 1. Okay, 4 times 1 by delta of x of 0. Okay, that means we need to find this represents 1 by delta of x of 3 represents a function whose first difference is x of 3. Okay, so that is going to be 1 by delta of x of 3, that is equal to this is 2 times x of 4 by 4. We know that what is delta of x of 4 by 4. Okay, so our previous discussions shows that delta of x raised to 4 by 4 will be 1 by 4 of delta of x of 4. We know that 1 by 4. What is x delta of x of 4? Okay, so this is going to be 4 times this 1 times x of 3. Okay, so that is going to be this x of 3. Here we have taken this h is equal to 1. We are considering x minus 1, x minus 2, x minus 0 here. This is the way we define factorial polynomial. So our differencing is with the factor of h is equal to 1 here. So we put delta of x raised to 4 is n times h times x of 3. Okay, this shows that the first differencing of this this x raised to 4 by 4 is nothing but x of 3. So that means 1 by delta of x of 3 is equal to x of 4 by 4. Similarly, we write 9 times this 1 by delta of x of 2. So that is going to be x of 3 by 3. So you can verify that the first differencing of this x of 3 by 3 will be x of 2. So and then that next will be 4 times x of 1, and we can apply any constant here. We know that delta of any constant will be 0. Then we can write 0 here, and corresponding to the 0, 1 by delta of 0 will be this constant function. Then now you can replace this 2 by 4 times what is x of 4. X of 4 will be x times x minus 1 times x minus 2 times x minus 3. So this will be the definition of x of 4. Similarly, 9 by 3, that is 3 times x minus 1 times x minus 2, and this will be 4 times x and z. Okay. Then when you simplify this, you can get a polynomial 1 by 2 x raised to 4 minus 7x square plus 14x times c. So this will be the final answer. So f of x will be this. When you evaluate the first difference of this f of x, that is first difference of this, you can easily get the small f of x. Okay. So this is the explanation of differences of factorial polynomials. Thank you.